Hi. In the previous some module we have covered up the inside of the operational amplifier and also IC, about the operational amplifier IC, and also we know about that the how op-amp is working and why it is called operational amplifier and all those things. Now today's module is a very interesting module that op-amp is op-amp. We can concentrate about the characteristics of the operational amplifier. Now, for the purpose of the characteristics of the operational amplifier, this is mandatory. What is the meaning of the characteristics? What is actually the theme of the characteristics? As suppose one student, considering one student, that you are suppose a student, so your name is students, it's coming from the study students, this coming from the study, this particular term the student's name is coming, student things is coming. But the things is that in case of ideal characteristics, students means always he is study, he or she is study. Student means always he or she is study. It's a very interesting things, but it cannot possible. It is a realistic reality. It's different, quite different. If you are students, you all times you are working different. You are in the different mode of actions. You are watching movie. You are Facebook, working with the Facebook. At present now you are watching YouTube, and you are calling your friend. You are playing cricket, playing football, several activity you are doing. But things is that you are students, but the ideal characteristics is you that you are all time study and study. That's why you are students. But things is that reality it's quite different. But in case of reality, it's quite different. So uh, hello my dear, actually I am very feeling about, I have a feeling about the operational amplifier, and I am very much accustomed, I am very much familiar with the operational amplifier. So like that way I am thinking that operational amplifier have one ideal characteristics, some ideal characteristics in operational amplifier. The ideal characteristics of the operational amplifier, the first one, the operational amplifier ideal characteristics is the input impedance equals to infinite. Input impedance is infinite. I am representing it as a input impedance is representing that Ri equals to infinite. Okay, and then that output impedance, first one is the input impedance, or next one is the output impedance is 0. Output impedance is 0. So what one is the first one is the input impedance is infinite. Second one is the output impedance is 0. So very important. I am at present now I'm studying about the operational amplifier, input impedance, output impedance. Like that way I'm just propagating step by step. Next is that uh, AOL open loop gain is infinite. AOL is infinite. Open loop gain is infinite. Open loop gain is infinite. what is open loop gain, what is input impedance, what is output impedance. I'll come to this matter. First you just learn about these things. Next is that next is that that bandwidth is infinite. Next is that the bandwidth is infinite. What is bandwidth? I also say that I'll again come in this matter later. Okay, so bandwidth is infinite. Third one is that third one yes, sorry, the fourth fifth one, sorry, fifth one is that that CMRR equals to infinite. CMRR is also infinite. CMRR infinite. Okay. So what are the part that is input impedance is infinite, output impedance is 0, open loop gain is infinite, bandwidth is infinite, CMRR is infinite, or we can say, we can elaborately say that it may not be required. When we can study about operational amplifier, then we can understand. Till now you cannot understand about this, what are the characteristics, ideal characteristics. Then when we just all the study about all these components, then you can understand what is actually the specific things of the operational amplifier. That another things is the VD, the voltage difference between two input terminal is equals to 0, and it is natural. Voltage difference between two input terminal is 0. Voltage difference between two input terminal is 0. So these are the ideal characteristics of operational amplifier. First is that input impedance is infinite. Second is that output impedance is 0. Then open loop gain is infinite. Then bandwidth is infinite. Then CMRR is infinite. Then VD, voltage difference, is 0. So these are the, or in some books they have writing much more, but these are more than sufficient in my point of view. I'm very much simply think about the operational amplifier. These are more than sufficient for you, and I'm explain how all these things are very much important fundamental themes to represent the ideal characteristics of the operational amplifier. And for that point of view, I want to say that these are the part are very important for the operational amplifier. These are the themes are very important for the operational amplifier. And to know about all this input impedance, output impedance, AOL, open loop gain, BW, bandwidth, and this CMRR and this VD, you must watch our next video module. Thank you very much. Hi. So in the previous case, we have already know about the op-amp IC and the ideal characteristics, but still now we cannot, we don't have any idea about the op-amp, IC, about the op-amp IC configurations, pin configurations. Basically, when the IC is developing, before to start this particular portions of the lecture, we have to say that at the first time when the IC is developed, this type of ICs looks, that is 1 2 3 4 5 6 7 8 numbers of pins like that. That CL100 transistors is looking. There is three numbers of lead, and here the how many numbers of leads are there. So this is the complicated, and after then a concept is coming in the market, that is the deep IC, dual impact IC. And dual impact IC is looks like that. That at present now the IC which we are used, that is dual impact IC, that is dual impact, and in one side, the left side is a notch, and it's a IC that is the dual impact, both side dual impact, two side impact. Some IC is the quad impact IC. That's IC we know that in the motherboard, that is the IC, that is the quad IC. and this is the dual impact IC, and op-amp is basically the 741 is the dual impact IC. And in case of this dual impact IC, one side is the notch, and in the notch side, the left side, from the left side, the pin configurations is start. How the pin configurations is start? Considering say IC, if there is one notch, and in the notch left side, its pin configuration is start from 1 2 3 4, and then from this side 5 6 7 8. So how it is, I'm again repeating that this is the IC, and where the notch side, from the notch side left of the notch, from 1 2 3 4 like this, so it's gradually increase, and then again from this side 5 6 7 8 like that way the one circuit is producing. And this is actually the IC configuration, pin configuration system of any kinds of IC. Because when you are using any IC, at that time the pins are not representing there, name of the pins are not representing there, you just counting it like that way, that is 1 2 3 4 5 6 7 8. Okay, very good. So next we go for the in this is the op-amp dual impact IC, and in this particular dual impact IC, what are the things, what are the name of this particular IC, what are the pin configurations, that things I just understand. So this is the op-amp, that's we have already know. This is the non-inverting terminal, that is the inverting terminal. We can use this plus VCC, or it may not be used in case of so this is the, in case of some sort of circuit, this is the plus non-inverting, that is the inverting, this is the output, this is the output. So you show in this particular in configurations, I first go for this particular two, this two pins is basically the inverting input pin. So this is the pin number 2, that is inverting input terminal pin. You show there is a non-inverting input terminal pin, it's a 3, pin number 3. So pin number 3 is the non-inverting input terminal pin. Now you go for the plus VCC pin. This is in here. The plus VCC pin is here. That is the 7 numbers of pin, which is 7 numbers of pin. And you show there is a minus VCC. That is, I think you know about that. I have already discussed that op-amp have two input voltage terminal, supply voltage terminal. That is plus VCC and minus VCC. And here you show this is the minus VCC. This is the pin number 4. That is the minus VCC pin. So so we have already understand 2 3 4 7. Then the output you show, that is the pin number 6. Output is representing the pin number 6. Okay, so these are the IC configurations of the operational amplifier. And at present now this particular IC is not present. This is the first time op-amp IC looks like that. At present now it is basically looks like this type of IC, dual impact IC. Now what are the other pins is working? What are the other activity or active pin? That is, you show there is a pin that is NC, there is a pin plus OF offset, there is a pin that is minus offset. So what is the meaning of all these things? I'm just discussed with you over here. That is, the NC means the no connections. These pins have no connections. Till now it's the operational amplifier, this type of 741, there is no connections IC. In case of the dual impact IC, this is the configurations rule. If there is the in the equal side, in the both side, the equal numbers of pins is required. So for that reasons, hope that for that reasons this NC pins is there. If their NC pin is not there, so the stress is not maintained by this particular IC. That's why the NC pin is there. And also in future, if there is any kinds of research and developments will done, and any kinds of other pin is required to introduce in the op-amp, then this NC pin will used. Now coming to the another matter, that is the offset and offset plus and offset null. One very important things I want to say, this op-amps is developed by this op-amp is developed by CMOS, MOS circuits and all those things. And for that point of view, inside of the operational amplifier there is a charge storage. Very nominal charge storage is there, and for that point of view, very small amount, a voltage error is representing, and that is called the offset null voltage. That is for the offset voltage, sorry, that is called the offset voltage. And offset voltage inside of the op amp. What happened inside of the op amp? There is for some capacitive value of the capacitive nature of the PN junction, NPN junction, and for CMOS and MOS, the one very small amount of very small amount of voltage is present in the operational amplifier. That is the offset null voltage. That is the offset null voltage. And I want to say you that if I am considering this is a operational amplifier, and if I am just connected these signals, these particular things plus a plus VC plus VCC side, and this particular things is a by wire in a minus VCC side, then a very small voltage we get in the output. We get a very small voltage, very small amount of voltage. That is also called the offset voltage. That is basically the offset voltage. For introducing the voltage in the plus VCC minus VCC, some voltage is inside of the operational amplifier which can be able to amplify and give the output also. So for that point of view, to overcome this particular error voltage when I am applying the inverting and non-inverting terminal voltage, so for that reasons this offset voltage is creating some problem inside of the operational amplifier. So this type of pins are developed, that is plus offset pin and minus offset pin. If the plus offset pin I am increase the voltage, then by using changing very nominal voltage change, we can able to nullify this output to the zero. And in case of minus offset voltage pin, if I am introducing the negative voltage in the minus offset voltage, sorry, if I am introducing the voltage in the minus offset voltage pin, at that time by using that, the negative voltage of negative offset voltage is neutralized and becoming zero. So that is the concept of the offset, and that is offset voltage inside of the op amp, and that is the concept of the offset pin, and that is the offset. It sometimes it is called offset pin, or sometimes it is called offset null pin, sometimes it is called offset null pin. And it actually, for that reasons, for this offset voltage, what are the current is developed in the operational amplifier, that is called the offset current, that is called the offset null current. Okay, so for that point of view, this is called the offset null voltage. One things I want to say that that is the bias current, plus bias current and minus bias current. That is the bias current in case of op amp. In case of op amp, the bias current is basically a very simple thing. That's if I'm introducing the voltage, supply voltage in the operational amplifier. So for that reasons, how the input is accelerated by the current, that is called the bias current. Input is accelerated by the bias the current, that is the by the current, that is called the bias current. And here these are the things, all the pins and all the pins we have already discussed and concentrate on it. Things is that this is the 1 2 3 4 5 6 7 8 pin IC operational amplifier, and all the pin in configurations is very important for the purpose of our practical and innovations. Okay, so next we go for a real characteristics of the operational amplifier. Real characteristics of the operational amplifier. Actually, we have already studied about the ideal characteristics of the operational amplifier, that input impedance is infinite. In case of input impedance is infinite, but there is a approximately value, that is the 2 mega ohm. In case of operational amplifier, there is some approximate value, that is 2 mega ohm. Okay, and we know that the output impedance is zero. And but the things is that in case of operational amplifier, the output impedance is equals to 75 ohm, representing the 75 ohm. Now we have already studied that open loop gain is equals to also infinite in ideal case, and here in the real case it is actually the 100 dB. Now CMRR, it's also infinite, we have already studied. So CMRR is infinite, but here it is the 90 dB value actually. Now the bandwidth of the operational amplifier, very very important, the bandwidth is 1 megahertz, and sometimes it can depends upon the input signal frequency, sometimes it depends upon the signal frequency. But there is a huge question mark, there is, I have already said, for the IC purpose there is several types of IC in the operational amplifier in the market, and for the different IC these data sets will vary, so for that reasons we are not concluded, we are not saying like that way that this things is the this RI, that is input impedance, is always 2 mega ohm. That things is wrong. The things is that we have considerings like that way, that's why I am keeping it to the approximations. Some, in case of one op-amp it may be like that, in case of other types of op-amp it's different, it's the value is different. But if these things is coming in the examinations, we have to find out, write down like that way, that for a particular specific op-amp we can consider like that way, that these are the value, Ri equals to this, R2 are not equals to this, AOL equals to this, like that. So step by step we can representing, not like that. So in a dot directly we cannot say, we cannot able to say that Ri equals to 2 mega ohm, the R not equals to 75 mega ohm, AOL equals to this, that's such as that. So in this particular sections module, we have already studied the IC pin for configurations and realistic value and realistic theme of the realistic characteristics of the operational amplifier. Thank you very much.